Hello, everybody. This is James Cole from NAF. I am the Corporate Engagement Relations Manager here at NAF. So excited to have you here today. We're going to be providing an amazing virtual guest speaker event. Matt Heverly is joining us. He's a robotics engineer at the Jet Propulsion Laboratory, which is part of NASA, as well as Caltech. He's going to explain what that means in a second. Matt was the rover driver on the Opportunity Mars Exploration Rover, chief mechanical engineer on the Athlete Hex-legged rover, and is currently working internationally as a mobility systems engineer for the Mars Science Laboratory. He's a super smart guy. He's going to share some great stuff with us today. As we start, I wanted to mention a few expectations we have for everybody participating. We have a lot of people on the line and we're expecting a lot more to be joining. So it's really important that we follow these instructions to ensure that everybody has an incredible experience. You're all muted. If you're not muted, please mute yourself. And you don't need to use your camera, but you're welcome to show your camera if you'd like. Thank you for submitting questions when you registered for today's event. Matt has reviewed them, and we'll be addressing many of them during his presentation. But you're encouraged to ask questions using the chat box and to interact with other participants from across the country. We're expecting participants from as far away as Hawaii, Puerto Rico, and the Virgin Islands, and nearly every state in between. Please keep your questions and messages appropriate and on topic. I will use your questions to ask Matt throughout, and we'll have a chance at the end of the presentation for you to ask even more questions. Finally, before I turn it over to Matt, I want to mention that there'll be a reflection activity that my colleague Kevin English will put into the chat box at the end. Please use that to capture your observations, thoughts, and further questions. For the educators joining us today, we're also developing some activities for you to help continue the learning with your students. And this recording will be, this presentation will be recorded. So you can use that. It'll be available probably early next week. And we look forward to this amazing presentation, but also working with Matt and his colleagues for future opportunities. Matt, thanks again for agreeing to do this. I'm going to turn it over to you now, and I will disappear. And if you see my face, I'm probably going to be asking a question. So thank you.
Awesome. Thanks, James. I appreciate the introduction. And happy Friday to everybody. Thank you guys very much for showing up and coming to talk about a couple of my favorite topics. Mars and robots. So I hope this will be a fun Friday afternoon presentation for everybody. So quick introduction. My name is Matt Heverly. As James said, I'm a roboticist at the Jet Propulsion Laboratory in Pasadena. And I spent the majority of my career working on robots to explore other planets and in particular Mars. So we'll try and talk a little bit today. I'll give you a little bit of history of our exploration of Mars. I'll tell you a little bit about what we found, what we know about Mars, what we're doing currently to explore Mars. And then we'll talk a little bit about all the fun, exciting, amazing things that we have in the future. That's going to continue our understanding and exploration of our nearest neighbor, the red planet of Mars. So I'll start a little bit with just where we're at and what I'm doing. I work at the Jet Propulsion Laboratory, which is one of 10 NASA centers around the country. And I love this charter. This is what we are here to do. We are here to serve the nation by exploring space in the pursuit of discoveries that benefit humanity. And it's a pretty broad, amazing charter that we have. We're really going out and we're trying to understand our solar system and our universe and where it evolved from and where it's going to, and trying to understand that in the context of really the benefits to all of us. And JPL is one of, as I said, 10 NASA centers, and our focus is on the robotic exploration of the solar system. So where some places, Johnson Space Center in Texas, they're focused on the astronauts, the humans that are going out and exploring. We're really focused on robots, right? That's why we're building all these amazing machines to go out and explore our solar system. And as I said, I've spent most of my career exploring this wonderful planet, the planet of Mars. And a little bit of the history, we've been exploring Mars for a long time. It started back in the 1500s when Galileo got out a telescope and looked up at this red dot in the sky. And we've been understanding more and more about Mars as we've gone along. It's always been an area of interest. And you can only understand so much by looking at Mars from Earth. So what we've done at the Jet Propulsion Laboratory, building those spacecraft, is we've tried to get closer to Mars and really understand what it looks like. And this is kind of our first close-up picture. We sent a spacecraft called Mariner 4 to Mars in 1965. And this was a flyby mission. So imagine you're in your car and you're driving along and you see the Statue of Liberty and you stick your head out and you kind of look at it, but you drive by, you don't really get out to stop and walk around and see anything. You just get the view of the Statue of Liberty as you drive by in your car. And that's kind of what we got with Mariner 4. We got this picture back from Mars, and it looks like this really barren, desolate landscape with craters and not much promise for anything that looks interesting in terms of finding life on other planets. And we kind of continued to explore Mars, though. We wanted to really understand what was there. And we've had several spacecraft since Mariner 4. We've had lots of orbiters, we've had lots of landers, we've had lots of rovers. And today we have this amazing robot named Curiosity that's driving around on Mars every single day, still operating. She's able to take pictures, and this is a selfie that she's, got a camera on the end of the robotic arm and reach out and take a selfie and transmit it back to Earth and post it on, a Twitter account and Instagram account. And this is kind of what we have today, exploring Mars. This is a selfie that was actually taken only about 4 weeks ago in mid-November. We're still doing lots of really good exploration. And this is what we're currently doing around Mars. And I guess I want to pause really quick and ask you guys to think and maybe put something in the chat. Why do you think we actually care about exploring Mars? We're spending a lot of our energy building these robots, trying to go to Mars. Why do you think we care? Why is Mars a place that we're interested in? Anybody got any ideas? Finding more life, right? Similar to Earth. Somebody wants to move there. Somebody wants to go live on Mars, huh?
I
James,
love all the answers.
Anything good in there?
Yeah, there's tons flowing through. Air quality, to borrow resources, water, understand life better. Wow.
I see a ton of awesome answers in there. Finding life. And I'm going to put up this picture while you're thinking about it. So here is a picture. These are both pictures from spacecraft of Earth and Mars, right? These are real pictures shown at relative scale. So you can see a little bit here. Somebody, Monique was in there. Mars may have been like Earth at one point. That's a very astute observation. So when we look at this, we notice that Earth and Mars, they're a little bit different size. Mars is about half the diameter of Earth, but they are very, very similar, right? They're both rocky planets. They have an underlying hard surface, unlike Jupiter and Saturn, kind of the gas giant planets. They're a little bit different than us. You can't really stand on that planet. But Mars is pretty similar to Earth. It's got a lot of the same geology on there. We can see volcanoes. It spins on its axis, and you can see it's on the North Pole up here. It's got some ice caps on the North Pole. We can see weather on Mars. We can really see that Mars is actually very similar to Earth. It also helps that it's our closest neighbor sometimes. Oftentimes when Earth and Mars are on the same side of the sun, they will be the closest planets to each other. Sometimes they're far apart when they're on opposite sides of the sun. But it does make it a relatively easy place for us to go explore. But one of the real main reasons we want to understand more about Mars is we believe that in Mars's past, it used to look a lot like Earth. So what you can see in this image that I'm showing is kind of Mars today on the left, and what we believe Mars used to look like a long time ago. And we believe Mars used to be very Earth-like. Both of the planets are about 4.2 billion years old. And in the first billion years, they were almost the same, right? They both had rivers and oceans and lakes and dense, thick atmospheres that helped keep them kind of warm. We talk about the Goldilocks zone. You're not too close to the sun that it's too hot, and you're not too far away from the sun that it's too cold. You're kind of just right in that Goldilocks zone. And when Mars and Earth were both there in their first billion years, they were very, very similar. But what we see is that Mars today looks different, right? What happened? What made Mars go from the picture on the right to the picture on the left, right? What happened to Mars that it's not like it used to be? So that's a perfect question in the chat right there. And the main thing that caused this to happen has to do with our magnetic field. And what we have on Earth is we have a spinning magma core at the center of the Earth, and that makes a magnetic field around the Earth. And this magnetic field protects us every single day. So there's particles that come from the sun, and this magical shield, this magnetic shield around the Earth, helps those particles get deflected away, and then they don't hurt us here on Earth. And for the first billion years on Mars, we believe that Mars had the same thing. It had a spinning magma core, and it had a magnetic field protecting it from the particles coming from the sun. But what happened was that spinning core went away, right? It used up all of its energy in its first billion years. And then those particles came, and you can imagine the atmosphere is actually just a bunch of particles of gases. And then when one of these high energy particles comes from the sun, it hits this particle of the atmosphere and it strips it away and sends it off into deep space. And gradually the atmosphere of Mars got less and less and less dense. And today it's about 100 times less dense than the Earth's atmosphere. And water can't actually exist in a liquid form on the surface of Mars right now. It goes straight from an ice. We found H2O ice on Mars, and then it goes straight to a gas. It sublimates, right? It boils off, it turns into a gas. And we can't actually have liquid water on Mars. But we found with our rovers really, really clear evidence that there used to be liquid water. So here's a picture that the Curiosity rover took as it was driving around exploring Mars. And what you can see are really thinly layered sedimentary rocks, right? This is at a place on Mars that used to be a lake. So as the water would come, it would deposit all of its particles. And this is the same exact phenomena that happens on Earth. We see these same types of rocks all the time on Earth. And the only way that we know that these rocks form are with the presence of water. So we know that there used to be flowing water on the surface of Mars. And when we look at some of the other discoveries that our previous rovers had made. This is the Curiosity rover again at a place called Yellowknife Bay. You can kind of see it's the shore of this ancient lake bed. You can kind of see the shore of the lake bed over here. And when we dig down, Curiosity has a drill on it, and it can collect some of those pieces of the rocks and put it into instruments. And we discovered all sorts of great things. We discovered that all the necessary building blocks of life were there on Mars. So the question that Curiosity was trying to answer was Mars habitable in its past? We believe in the first billion years, right? It had this water, but did it have the other things that are necessary for life, right? And we know that life takes a few different things. We know that every living thing on Earth needs water to survive. So that's a necessary ingredient for life. We also know that it needs these basic building blocks, right? Like the Legos of life are the carbon, hydrogen, oxygen, nitrogen, these organic molecules. Some people call them the chnops for the carbon, hydrogen, oxygen, right? They're these organic building blocks that make life. And what Curiosity discovered in this picture here, when it took those pieces of Mars and analyzed them in its very sophisticated equipment, was it found those building blocks. It found large amounts of those carbon, oxygen, nitrogen building blocks. We found sources of energy, right? We've got the sun. We can get energy from the sun. There's also some chemical reactions in the subsurface. We have the possibility for life to exist in the subsurface. And the analogy that I like to make is, if you've ever made a cake, you need flour and you need eggs and you need water and sugar, and you put all these things in a bowl, right? But that doesn't mean you have a cake. It takes a lot of, you got to mix it and you got to bake it, and then maybe you'll get a cake out of it. And what we've done is on Mars, we found all the ingredients for the cake. We found all the ingredients that we know are the necessary things to make life. We know that it was inhabitable, right? It was a place that life could have existed. And the question that we're going to ask now is, was Mars ever actually inhabited? We're going to go look for evidence of that past life on Mars. And I'll pause really quickly. I love this picture because we've got people from all over the country here today. But for us, I live in Southern California, and oftentimes I go out in the desert, and it looks a lot like this. This is actually a picture of Mars, and sometimes I can see places on Earth. You look at pictures of a Grand Canyon, or you look at places in the desert. And this is just another reflection of, man, our planets are really, really similar. And it's pretty cool to see how Mars can look so much like Earth. So I'm going to come back to, our question about, was Mars ever inhabited? So we're going to go look for evidence of that ancient life. And a lot of people, when you think of ancient life on Earth, and I think of a dinosaur bone, right? Like I think of, we're going to go look for dinosaurs, and the evidence of those dinosaurs are the fossils that their dinosaur bones leave behind, right? But we don't actually think that we're going to go look for dinosaur bones on Mars. We're going to look for something different. We're going to look for fossils of microbes. And the reason that we're looking for this is because on Earth, if Earth and Mars are both about the same age, they're both about 4.5 billion years old. And on Earth, in the first billion years of evolution on Earth, life only got to microbes, right? We didn't have enough time to get to fish and birds and dinosaurs and people and all that kind of stuff. In evolution, a billion years only got to microbes. So if we believe that for the first billion years, Earth and Mars were the same, and then Earth continued along, but Mars stopped, we don't think that evolution would have had enough time to get past microbes. So these are the types of fossils we're looking for. These are called stromatolites. They're kind of fossilized ancient microbial mats. And this is a place in Australia where we see some of the oldest evidence for life on Earth from about 3.5 billion years ago, about a billion years after Earth formed. This is what we think was there. And these are the fossils on Earth that are preserving that evidence of life. And the way that we're going to go do that on Mars is with this amazing rover named Perseverance. Have any of you guys ever heard of the Perseverance rover before? Tell me in chat if you've heard of this rover before. I see a lot of yeses, maybe a couple no's. After today, you're going to be able to go tell everybody all about this really cool rover. So I'm going to play a quick video here that shows a little bit about us building this rover. The engineers that designed the rover, you could see the technicians that are assembling the rover. We have a team of scientists who are asking all of the big questions. We have a whole bunch of people that are machining the parts. It's a whole bunch of metallic components that come together, people writing the software that's going to make the rover able to drive around on Mars, people that are designing and building the radios so we can communicate with it, people designing and building the way that this rover is going to land on Mars with parachutes and all this stuff. So it's a gigantic team effort to make a mission like this come together. And as you saw, we built this rover, and then, oops, let me see if I can get to my next slide here. And then on the 30th of July, this summer, 2020, we launched our rover off on its journey to Mars. And the rover Perseverance was named by somebody named Alex Mather. He's a 7th grader from Virginia. And all of our rovers are named by students around the United States who write essay contests in order to name them. So our previous rovers were Spirit and Opportunity, and we had Sojourner, named after Sojourner Truth. And Alex named the Perseverance rover back in February, before we had really kind of seen the pandemic, and people didn't realize how apt a name it was, because the team has worked through, the environment that all of us are in, working from home. And we had a small team that was continuing to assemble the rover and put it on this rocket and get it on its way to Mars. So even though we've had all these challenges with our global pandemic, the team has persevered and helped Perseverance on its way to Mars. So I'll pause here and ask another quick question. How many of you would want to go to Mars? If you think about Perseverance is on its way, I see lots of yeses, very excited people, a couple of no's, but lots of people in here. James, do you see anything in here that strikes you?
Yeah, there's a few folks, I think not yet, possibly. Some folks are saying, no, it's too old. They're split on the idea.
So
people think they'd get bored pretty fast.
Yeah, one of the things I'll ask is, how many have gone on a road trip? And when I talk to people about going to Mars, I think it's kind of like a road trip, And for me, I've been on a road trip going all the way across the country. It took a little more than a week. And, every once in a while I'd be able to get out of my car and cruise around and see some sights and, get back in the car and keep driving. And so when you think about, do you want to go to Mars, think it's a really, really long road trip. So Perseverance launched on July 30th, and here's some stats about where it is right now, right? Perseverance is about 68% of its way to Mars, and it's already gone 320 million kilometers from Earth. And it's going to land on February 18th. So at about 12:30 Pacific time on February 18th, you'll be able to watch. You can get online and you can see this, and everybody's going to watch it at the exact same time. Christian Fox's birthday is that day, so he's going to be able to watch a rover land on his birthday. And what we'll see is everybody's going to watch it at the same time, right? We don't watch it first at NASA and then release it, so you guys can all be part of the excitement of watching this thing land, hopefully land successfully. But it takes about 9 months to get to Mars. So you can think about that road trip, right? You'd get in your minivan and you'd have to drive for 9 months, right? And there's no way to get out of your minivan and go see some sights. There's not a whole lot between Earth and Mars. So you'd have to kind of stay in your minivan for 9 months to get there. And the other interesting thing about it is, as I said, Earth and Mars are close every once in a while, but sometimes they're on the opposite sides of the sun, and they sync up about every 2 years. So if we would have missed our launch opportunity this July, we would have had to wait for 2 more years before Earth and Mars are close enough again that we can launch a spacecraft there. So if you want to go to Mars, you'd have to go there and then wait for 2 years, and then maybe you could get on your return trip to come back to Earth. So it's a pretty big endeavor to be able to get people to Mars, but someday maybe we'll be able to do that. So I'm very excited. Perseverance is on its way. It's going to make some amazing discoveries. And the place that we're sending Perseverance on Mars is a place called Jezreel Crater. Now, this was a giant impact crater, right? We had this big meteorite come and hit Mars, and it made this big old crater. You know, you can look up at the moon and you can see some big craters on the moon. And this happened in the same way, but it happened back when Mars used to have its atmosphere and its flowing water. And what you can see is this crater turned into a lake. And you can actually see this lake inflow. You can see the river that kind of flows and goes into this lake. And then you can, you know, the lake rises, and then there's some place, and you can see it right over here on the right-hand side of the screen, where the water flows out of the lake, right? So this was a place where we had water coming in, sitting around for a while, and then flowing out the other side, just like a lot of lakes here on Earth. And the place where we're really going to target in this is the delta. So you can see this black circle right here. This is our landing ellipse. This is the rover will land somewhere in that circle. And we want to get as close as we can to that delta feature. So here's the delta closer up. This is just like a delta here on Earth. And the reason we want to go to this delta is, you can imagine when there was rain on Mars, you know, the rain would wash everything off of the surface and into this river, and it would flow down the river, and it's flowing fast, just like a river on Earth. And then it hits a standing body of water in a lake. And then all the stuff kind of settles out of the water. And that's what makes a delta here on Earth. It's all the stuff that's carried into the lake from the river, and it kind of settles out. And then, you know, a little bit of mud comes on top of it, and any sort of evidence of life would have been buried in this delta. And we find tons of kind of fossilized evidence of past life here on Earth in our deltas here on Earth, because it's a great way to transport stuff and then bury it so that it stays preserved. That's how we get fossils, right? You kind of bury it, it gets a lot of pressure on it, turns into a fossil. And this delta is starting to erode away on Mars due to the winds that are there now, and exposing a lot of this area. So you can see the front side of this delta is all kind of freshly exposed, and that's the place where we're going to go fossil hunting. So just like a lot of people on Earth, when you go fossil hunting, you got to know where to look in the right spot for fossils. And this is where we think we're going to go look on Mars. Yeah.
There's a lot of conversation in the chat box about fuel and how the rocket gets to Mars. I know you have some insights about how much fuel it takes and whatnot to get a rover all the way over to Mars.
That's a great question. I'm going to go back a couple of slides and show you this picture. So when you look at this rocket, right? This whole rocket, everything in here is all fuel. The rover is just right up at the tippy top, right? It's just a small portion. So we're only, a few hundred kilograms, a couple of times the size of a car. The rest of this gigantic rocket is all fuel. So it takes a ton of fuel, and we use liquid fuel to get the rocket out of the Earth's atmosphere, right? And then it's kind of orbiting around Earth. And then we use a solid fuel. We point the spacecraft to Mars, right? And then we hit the solid fuel go button, and then off it goes to Mars. And you can see how fast the rover's going. It's going 89,000 kilometers per hour. We go really fast with that secondary rocket, the second stage of that rocket that helps push it on its way to Mars. So that's how we get there. So the majority of what we launch into space is just fuel with a little bit of payload up on top. All right, so I'm going to talk a little bit about, once we get there, the next challenge is how do we land, right? We are going, as you saw, tens of thousands of kilometers an hour, and somehow we got to get our rover safely down onto the surface of Mars. So the first thing that happens is we hit the Mars atmosphere. So even though it's really thin atmosphere, it's about 100 times less dense than the Earth's atmosphere. You can think of it like I'm running through our air and then I hit some water, right? And the water might slow me down because it's much more dense than the air. So we're going through space where there's no atmosphere, and then all of a sudden we're going to hit the Martian atmosphere, and we're going to slow down a little bit. And it's going to generate a ton of heat, right? There's all this friction that comes from hitting the atmosphere, and we have a heat shield that kind of protects the rover inside there. And that slows us down, but it doesn't slow us down that much. And then what we're going to do is we're going to pop open a parachute. And this is a gigantic parachute that opens at Mach 3 as we're going. So the loads on this parachute are huge, and there's tons of engineers at JPL who have to design these very, very capable parachutes that have to package into this really, really tiny volume. So we go with our rover and we hang on the parachute, and you can kind of see the rover tucked up in there in what we call the back shell. And we're slowing down on the parachute, but it really doesn't slow us down that much. Again, remember, we've got a really thin atmosphere on Mars, so it's not going to really help us come to a speed like on Earth where you could kind of slow down and land like if you were jumping with a parachute out of an airplane here on Earth. So we've got to do something else. And this was the first time I saw this, I thought, this is just crazy. Is this really the idea that we're using? But we're putting a giant jetpack on our rover. So this rover is about the size of your car. Can you imagine if you strapped a jetpack to the size of your car and your car was able to fly around? But that's what we're doing. We will drop this, we call it the descent stage, out of the back shell, and it will kind of fall down, and we'll turn on the engines, and it will, lower us down and slow us down. And then it's going to hover about 10 meters above the surface. And while it's hovering, we're going to lower the rover down on this string, right? We've got three structural bridles, we call them, that lower the rover down, an electrical cable that's going to allow us to continue to talk to the rover, and the wheels are going to deploy, and we're going to get everything ready. And then it's just going to lower down a little bit more, and we will touch down. The rover will touch down on its wheels on Mars. And then it will cut all of those bridles and that electrical cable. And then the jetpack is going to fly away, and it will crash somewhere, hopefully very far away from the rover. And that is the way we will land our rover on Mars. And the crazy thing about that is we've already done that once, and it worked. That's how we landed the Curiosity rover on Mars, this exact same thing. So when you look at the rover that we're going to build, the Perseverance rover, it looks a lot like the Curiosity rover. And what we're trying to do is we're trying to build upon our success. So whenever you guys do something, maybe if you are making a YouTube channel, right, and you have a really successful video, the next time you might use the same method, right? I'm going to use the same speaker to record, or microphone to record myself, and the same camera, and I'm going to post it in the same way, but I'm going to maybe talk about something different, right? I'm going to have some different content to talk about in my next YouTube video. And that's what we're doing, right? We are using the same kind of fundamental rover and the same way to land the rover on the surface of Mars, but it's going to do a whole bunch of different stuff. So this rover is going to have some amazing things. It's going to have a lot of cameras. We've got some mass cameras, and SuperCam is actually a laser. So we're going to be able to shoot a laser at the surface of Mars, and it will heat up a rock so hot, it'll turn the surface of the rock into a plasma, and we'll look at what light comes off of that, and we can tell what the minerals, what the chemicals are that make up that rock. It's got a subsurface radar, so we'll be able to understand the structure below Earth. And then it's got a bunch of really amazing spectrometers out on the end of its robotic arm. It's got Pixel and Sherlock, and what these will do is these are actually going to map those minerals. So what we know about life is that life makes structure. And we're going to go look for structures that have those building blocks of life. Right? So if you've just got a bunch of nitrogen kind of mixed in there, or carbon kind of mixed in there, that can happen either from life or just from geology, right? There's kind of both ways for it to happen. But if all that carbon is lined up in a line, that's a telltale signal that there was something that was doing that organization and structure of those carbon molecules. And that's what these spectrometers are going to do. They're going to be able to go look for those things that might be the highest chance of being made from life. And then we've got a couple of cool experiments on this rover. So our first experiment that I'll tell you about is Moxie. So this is going to produce breathable oxygen from the Martian atmosphere. So the Martian atmosphere is made of CO2. If you landed on Mars, you wouldn't be able to breathe. And breathing is kind of important for humans. We like to let them breathe. So we're going to try and make breathable oxygen from that atmosphere. So this is an experiment that is kind of helping pave the way for astronauts, or any of you here that said, yes, you want to go to Mars and you still want to do it after the 9-month road trip. You probably want to make sure there's some oxygen to breathe once you get there. This will be the experiment that will help prove that that's actually possible. And the other experiment that we're taking is Perseverance's sidekick, and it's named Ingenuity. So this is a drone helicopter that we are sending with Perseverance to Mars. This is the first time we've ever had a powered flight vehicle on the surface of another planet. It's a really small helicopter, or the payload. It's just kind of the size of a really tiny computer and a GoPro camera that's going to fly around. But the blades of the helicopter are really long. They're about as long as my wingspan because that atmosphere is so thin, right? We could fly a little tiny toy quadcopter with, propellers that are this big here on Earth because we have that dense atmosphere. But in order to do it on Mars, we have to have these giant propeller blades. So this is going to be Ingenuity that's going to be able to fly around, and a really cool experiment that we're doing with our rover on Mars. Now, before, when I was talking about the science that we're going to do, we've got those spectrometers that are going to be able to map those chemical signatures of potential past life. But we're trying to really prove if life ever existed on Mars. And a saying that I really like is that extraordinary claims require extraordinary evidence. And we don't think that we can provide enough evidence with the instruments that we're sending to Mars. So what we're going to do with Perseverance is we're going to put a drill on Perseverance. And this is a coring drill. We're going to drill down into the surface of Mars. And you can see this little piece of rock here that's about the size of a piece of chalk. Back when we all used to be in classrooms, there was maybe chalk on a chalkboard. And then we're going to collect that. And then Perseverance is going to take that and it's going to put it in a little tube, right? And these tubes are going to have then samples of rocks on Mars where we believe there could be some of these fossils of these ancient bacteria. And we'll leave these tubes on the surface of Mars. So we'll drive around and we'll land someplace and we'll drive to an area. We call it a region of interest, something that's scientifically interesting. And we'll collect a few samples. And then we'll drive to a place where we're going to put these on the ground. We're going to call this a depot, right? We're going to put these sample tubes into a depot. And then we're going to drive somewhere else that might be interesting. We'll drive back to that depot, put a few more sample tubes on the ground, go somewhere else, something interesting, see if we can find something scientifically cool, collect some more samples, put them in tubes and go back and put them in a depot. And now we have a cache, right? A cache of these sample tubes that Perseverance will collect and we're going to leave on the surface. And who might have an idea of why are we putting tubes full of rocks on the surface of Mars? Why are we just leaving them there? Why would we do that? Anybody have any ideas? To see if they'll move. Yeah, we'll see if there's little bugs in the tubes that'll move them around. James, you see anything in there?
Yeah, for future missions to collect, to send people later to examine them. I think they're getting close.
Yeah, I think we got a lot of good answers in there. So the future missions, that's what we're going to do. So we are going to send another mission after Perseverance. And this is the mission that I'm working on right now, where we are going to land another spacecraft on the surface of Mars. And then on the top of this spacecraft is going to be a small rover. You can see it kind of upside down here with its wheels packaged up. It's kind of like a little upside down bug on the surface of Mars. And we'll take this rover and we'll put it down onto the surface. And this is called the Fetch Rover. And it's called the Fetch Rover because it's going to go fetch these tubes that we've left on the ground. And this is an international collaboration. The European Space Agency is actually going to build this rover. And we are going to, JPL and NASA are going to build the lander. So we're partnering between the United States and Europe in order to do this really, really big mission. So this rover is going to go collect these samples and then it's going to come back and it's going to return them back to that lander, right? So it's got on the front of it, you can see here this rack full of all these tubes, kind of test tube size tubes. And then a robotic arm is going to reach out and grab these tubes and bring them back and put them into a rocket on this lander. So we will load, I like to call it a box full of rocks, right? It's the most expensive rocks you could ever imagine. And we will take these rocks and we will put them in the surface or into the the top of a rocket. And this will be the first rocket we will have ever launched from the surface of another planet. And again, the majority of this rocket is all fuel, just like on Earth. It's much smaller, right? This is only about the length of a few meters, so about the length of a short car. And on the top of this is our box full of about 30 rocks. And we will launch it up into orbit around Mars. But this little rocket, right, it's much smaller than the rocket that we had on to launch our rover from Earth. And it's not going to have enough fuel to get it all the way back to Earth. So what we're going to do is we're going to send another spacecraft that's going to go orbit around Mars, and it's going to go find this box full of rocks. It'll be about the size of a basketball. You can see it white right over here. And this basketball size orbiting box full of rocks will be orbiting around Mars, and we're going to send a spacecraft to go rendezvous and grab that and ingest that box full of rocks back into the spacecraft. And then this spacecraft, you can see it's got really big solar arrays. It'll have a lot more power. It'll be able to turn around and it'll be able to come back to Earth. And then we will eject this basketball sized box full of rocks into something similar to what we had from landing on Mars. And it'll be in a heat shield, and it will come and it will land on Earth, and it will crash into the desert of Utah. And then we can go find those rocks returned from the surface of Mars. And the reason that we want to bring them back to Earth is we can only make our instruments so small here on Earth. And we can send a couple instruments to Mars. But as I said, the burden of proof necessary to show that there may have been life somewhere else in the solar system is really, really high. So we're going to need to use scanning electron microscopes and all sorts of spectrometers and crazy things that we have here on Earth to be able to really look and answer that question about, is life unique to Earth?
Matt,
so, yeah.
good question. There was a good question about finding something more useful than rocks. Would you mind explaining why rocks would be important?
Yeah, that's a good question. So we don't believe, as I said, Mars changed after its first billion years. We don't really believe it's possible for there to be what we call extant life, or something that's still alive on the surface of Mars. So all that we can look for are fossils, right? It's those evidence of preservation of past life. And that's how we know that, dinosaurs existed on Earth, is that we have evidence of their existence through their fossils. And we're going to go look for the same exact things on Mars. We're going to go look for fossils. And, I call it a box full of rocks. Hopefully it's a box full of fossils. And we will have evidence that shows that there was life on Mars, but we don't actually know. And that's part of the beauty of exploration, is that you don't know what you're going to find. We may find that there was life on Mars, and we may not. We don't know the answer ahead of time. And that's the fun of exploring, is that you don't know the answer. And that's one of the reasons I kind of love my job. And one of the other things I was going to talk a little bit about is, what it takes to do this job, not just my job, but the job of all 3,000 people that built this amazing rover and its sidekick, Ingenuity. And one of the biggest ones I would say is problem solving, right? Nobody's ever done this before. There's no blueprint or roadmap for how to make a giant nuclear powered rover to go look for fossils on Mars. We have to invent all this stuff, and you have to solve all the problems that are in your way. How do we land a rover on Mars? How do we power the rover? How do we communicate with the rover? How do we take the pictures? All these things are problems that we have to solve, and you're kind of given a new problem every day. And oftentimes in the solving of those problems, you have to be creative. There's nobody that knows how to do this. How do you make a drone helicopter that can fly on Mars? We had to be really creative and really innovative in trying to invent these new things. And the last thing I think that it takes, as I kind of hinted to, is there's 3,000 or so people that work on this project. And it takes a lot of collaboration to get everybody working in the same way. I don't know how many of you've worked on team projects before, but somebody might think, no, I want to do this, and no, I want to do that, right? And if you've got a bunch of people working in different ways, you don't always get a good product at the end. So you have to know how to collaborate and give compromise, and work together as a team. And I think these are some of the biggest qualities that make our team successful. And then I wanted to reflect kind of personally for a couple of minutes about, like, why do I love my job? Because I do. I can't believe I get paid for this, right? Like, I build space robots for a living, and I get to go drive them on the surface of another planet. Like, it's just the most incredible job I could ever hope for. But one of the main reasons that I love it so much is because it's really hard. And I don't know about you guys, but when I accomplish something that's really challenging, the sense of pride, the sense of accomplishment, it's almost addictive, right? I remember sitting and watching when Curiosity landed on Mars, and I had worked on that mission for about 7 years before it landed there. And to think of all the things and all the challenges we went through, and then it worked, right? And then we've got a robot taking selfies on Mars, posting its pictures to Instagram, like, oh my gosh, that's so amazing. And it was so hard to get there. And I want to go do it again because it's so rewarding to have accomplished something that was so challenging. The other reason I love my job is because I do learn something new every day. I'm trained as a mechanical engineer, but I get to learn about fossils, and I get to learn about magnetic fields around planets, and I get to learn about rockets, and all these sorts of things. And to me, that sense of constant lifelong learning is something that I strive for. I feel like I'm smarter today than I was yesterday because I learned something. And to me, that's empowering. That's making me feel better every day about how much I can contribute to whatever I'm working on. And the last thing I would say is the projects that we're working on, right? These are the most fundamental questions that humans have asked. Are we alone? Is there life somewhere else in the solar system? These are really big questions. And I think they make the world a better place, not only in being able to answer those questions, but in the technology that they develop. So I always like to say that our Mars rover is the original self-driving car, right? Like, it has to drive itself around Mars. And a lot of the technology that we developed to make those Mars rovers drive autonomously around Mars are being used by Google and Uber and all the companies that are making self-driving cars now, that hopefully we will have safer cars. We will have, we wouldn't have cell phones if we didn't try and go to the moon, because we had to figure out how to talk to astronauts that were a long ways away. And all those, when you're solving these hard technical problems, there's oftentimes technologies that get developed that help us in our everyday life. And I like to be able to think that I'm making a contribution to those things. So I'll leave you with the motto that we have of JPL is to dare mighty things. And we don't try things because they're easy. We try things because they're hard and they're important. And we are on our journey. You can see Sojourner here on the left was our first rover that ever landed on Mars. And Spirit and Opportunity, Curiosity and Perseverance on its way, and the Mars sample return. And eventually that'll lead to humans walking around, making exploration and us being a multi-planetary species. And that's a really big, mighty thing that we're trying to do. But I absolutely love doing it every day. Thank you guys very much for listening. That's all that I had to share with you today. And I would love to hear some questions that you might have.
Yeah, Matt, that was amazing. I'm getting messages how amazing that was. So just thank you. Julio, I see you have your hand up. If you want to unmute yourself and ask a question, I'm sure Matt would love to answer it.
Hello, my name is Julio. I come from Torella High School. Okay, and my question is, would a rogue star ever hit the Earth and cause it to fall out of the solar system?
Okay, thanks Julio for your question. Let me make sure I understand it. Would anything ever hit the Earth so hard that it would make it move out of our solar system? Is that your question?
Yeah, like due to gravity.
Yeah, so that's a really good question. And one of the things that people at NASA are working on is protecting our planet, right? We're not just exploring other planets, but we're trying to protect our planet. And I think that if you look at the current theory for how the dinosaurs became extinct, it was because something really big hit the Earth. And it didn't cause Earth to be pushed out of the gravity influence of the sun. I don't think there's anything that could be that big that would do it. But it would change our planet forever, right? I think that the dinosaurs became extinct because of the global change in our atmosphere, because of all the dust that came up from this large impact. So we are attempting to protect ourselves from that, because I don't want the same thing to happen to us that happened to the dinosaurs. So, but thanks, Julio. Great question.
And my last question, can I ask one more question?
Yeah.
What's your thoughts on the new space race?
Between who?
Between like Russia's have to try and get to Mars.
Yeah, so I think it's wonderful and I welcome it, because I think it helps, and I think it's less of a race against each other and more of a collaboration, right? The Russians they have been launching our astronauts to the space station for a long time. We're partnering with the Europeans. There's an Indian spacecraft orbiting around Mars. There's spacecraft from the United Arab Emirates on its way to Mars right now. And I think that all of this is helping us all get better at exploring space. And the more people that do it, the better we're all going to be at it. So I welcome it.
All right, thank you very much, sir.
Great questions.
Dustin, did you have a question you wanted to ask Matt? Please state your school too and what state you're from.
My name is Dustin Tack. I come from Oak Ridge High School in Orlando, Florida. And JPL works with NASA, or it's part of NASA, but I'm wondering does NASA collaborate with private companies such as SpaceX or Blue Origins?
Yes, great question. And coming on to Julio's question too, the more people we have doing space exploration, whether they be government entities or private entities, I think the better we're going to be. So that Mars sample return mission will most likely launch to Mars on a SpaceX rocket. And one of the things to think about is SpaceX is a private company, right? They are trying to make money exploring Mars. And I think there's a role of the government to answer big questions, right? There's not a lot of money in answering the question of, is life unique to Earth? And I think that's the role of kind of NASA to do it. But we can partner with SpaceX, and they are making it more affordable for us to ask these questions, because they're building rockets, and the more they build, the cheaper they become. And that means the more missions we can do and the more important questions we can answer. So I think that the collaboration with private industry is a wonderful thing that's going to enable us to do a lot more science.
Oh, thank you.
Great question, Dustin.
Laura, I see you have a really good question about backup plans and contingency planning. I didn't know if you wanted to unmute yourself and ask that, or if you wanted me to read the question from the chat box, but.
Yeah, sure, you can hear me because my computer might be glitchy. Can you?
So, yeah, we can hear you.
We hear you.
So I was wondering, do you have any backup plans if something doesn't go right? Like if the rocket you're planning to launch back into orbit doesn't make it, or like your rover doesn't make it or something? Do you have any backup plans for that?
Yeah, you should totally become a systems engineer, because that's exactly what systems engineers think about is, what if something doesn't go right? How do we still do our mission? So very good question. And we do try to make some of those contingencies. So we will likely make a second depot of sample tubes that if this mission fails, all those don't blow up on the rocket, and that a future mission can go collect some of those. So we're collecting enough samples to distribute them. We also have some backup plans where if that orbiter around Mars to get that box full of rocks doesn't work, we are making it such that basketball-sized container can actually survive in orbit around Mars for a decade or so. So we could go send a different spacecraft to go grab it if that other spacecraft didn't work. So a good engineer is constantly thinking about what can go wrong and mitigating those risks. We can't mitigate all of them. If our parachute doesn't open, we are not going to land safely, and therefore we have to really make sure that our parachute opens. But with a lot of other things, we try to mitigate those concerns as much as we can. It's a really good question. You should totally be a systems engineer, Laura.
Brandon Baker, I want to ask you to unmute, and then it looks like Irvin Cruz, you'll be after Brandon to ask a question.
Hey, my name is Brandon Baker. I'm a junior from Edgewater High School, and I was wondering, like, how would I be able to get the chance to work with things like satellites, doing planetary observation, like things like that?
Yeah, that's a great question, Brandon. So I think the first thing to think about is, what do you want to go study in college? And if you're going to study engineering, if you're going to study science, all those are, you can have a career in space exploration with all of those, right? With my engineering knowledge, I could build cars or toaster ovens or Mars robots, right? And I chose to go work in the space industry. But there's those basic skills of engineering or science or whatever. And then the other thing I would encourage people to look at is an internship, right? We hire a lot of students to come work for the summer with us at JPL or whatever other institution. And there's an opportunity for you to get some exposure to that work and to do some of that work while you're still a student and understand if it really is a career that you would want to pursue or not. So I would really encourage you to look into those internship opportunities. For us, it's mostly in college, but I think that there are a lot of high school internship opportunities as well.
Awesome, thank you. Esperanza, I'd like you to go after Irvin, if that works for you.
Hi, I'm a freshman at Robert Morgan, and my question is that when do you think that the first human would land on Mars?
Oh, that's a really hard question, Irvin. It's a good one. And I don't know, there's some people who think that it's going to happen really soon. I mean, I think that SpaceX and Elon Musk are pushing to do it in, the next 10 years or so. I think it might be further beyond that. There's a lot of challenges that we have to solve. You have to make oxygen. You have to find a way to provide food. You have to protect them from radiation. There's tons of engineering challenges out there. And if you want to be one of those engineers to help solve that problem, I think that we will be continuously solving those problems. I think it's likely 20 or more years, maybe 20 years or so before that seems credible. But it's well within all of our lifetime. And I hope it comes sooner rather than later. And if you want to go be part of that solution, please be an engineer and help us solve all those problems.
All right, thank you. Thank you for your response.
Thanks, Irvin.
Thank you. Esperanza, did you want to unmute yourself? I think we have probably room for a couple more questions. Oh, looks like, are you still there? Disappeared from my screen.
Can you hear me?
Yes, there you are.
Oh, okay. Hi, my name is Esperanza Salazar, and I am a sophomore at Mission Oak High School. And my question to you is, what did you have to do to be where you are now? Like, what did you have to do to work at NASA?
That's a good question. I worked really hard, and I got lucky. But I think the biggest thing for me was I found something that I was passionate about, right? When I was in junior high and high school, I loved to take things apart. I would disassemble a whole bunch of stuff and just see what happened inside and see how this worked and how does my bike work and how does this microwave work, and and my parents weren't so excited because I was constantly taking things apart, but it really made me wonder, how do these things actually get made, and that developed a passion in me. And then I started studying engineering to go answer those questions. And I think that because I love it and because it was something that I could go study, your passion aligns with your education, and then you find something that you absolutely love to do. So my input is, if you can find that thing that you like, and if you want to contribute to space, whether that be mechanical engineering, do you want to build gears and bearings and things like that? Or is it software and you want to write programs to make the rover drive around autonomously? Or is it science? You want to be the one to go investigate those fossils. If you can find the thing that is most exciting to you, and then you can go study that, then that is the way to develop a true expertise and passion for something that will translate, hopefully, into a job that you absolutely love to do every day.
That's amazing. Zachary Neely.
Hi, I'm Zach. I'm from Tulare, California, from Mission Oak High School. I'm a freshman, and I wanted to know on how long it really takes you guys to build one of these rovers, and how much money does it cost?
Yeah, good questions. So it takes about a decade. It takes almost 10 years to build these rovers from scratch. And so you can imagine the people who worked on the parachute and that jetpack for the rover, they've spent the last 8 to 10 years of their career doing this one thing. And it has huge implications. And then when it works, the sense of pride and accomplishment and everything that they feel. And it takes a lot of money. It's $2.5 billion for this mission. So both the Curiosity rover and the Perseverance rover cost about the same amount, which is $2.5 billion. And that's the money to pay the engineers and to build the things and to pay for the rocket and pay for everybody to operate it. So they are not cheap. It costs a lot of money, but I think we get a lot of return on that investment. We're, as I said, developing technologies that's used every day in our lives. We're answering fundamental questions asked by humans for all of human existence of, are we alone? And I think it's a small price to pay personally.
So we are up against time here. I want to respect Matt's time and everybody's time on the line. So I want to give Matt a second to make any closing comments. And before he does that, just give everybody a big thank you for joining today. I know there were a lot of questions we weren't able to answer. I highly encourage you to direct questions through your teachers, through your academy, to NAF, to me, Cole, JCOLE, at naf.org, and really encourage you to complete that student reflection that my colleague, Mr. English, shared in the chat box, and use that as a way to route questions through to NAF with your teacher. So Matt, any closing remarks? And as you think about that, I just want to give my sincerest gratitude. Thank you. You are amazing, and this has been so wonderful.
Thanks, James. I appreciate you having me. And I want to say thanks to everybody who came on your Friday to come listen to this topic. I think I love having the opportunity to share what we're doing with our country. I think it's really interesting work. I think it's important work, and I appreciate you taking the time to do it. And I just want to encourage you, as you're thinking about what you want to do in the future, there's a ton of problems to be solved here. And if this seems interesting, please go pursue engineering, go pursue computer science, go pursue geology, whatever it is that you think is going to be the part of this story that you want to be your part, that you contribute to. It's a really, really amazing career, and we need a lot of really smart people. The questions that were asked today were incredible. I talked to a lot of students and I don't get that level of question. So thank you very much. And please go help us dare to do mighty things. Enjoy your weekend. Thank you.
Thank you, everybody. Thank you, Matt.